Hi class, today we're talking about linear systems and solving it by use of substitution. A linear system is two equations with two unknowns. These two equations, if you were to graph them, would be lines. And as you see, you could graph it on an xy axis, and this would be a line, this would be a line. When you solve linear systems, you're looking for the point of intersection. It's possible that there are no intersections if the lines are parallel. It's also possible that there are infinite solutions if the lines are coincident or lie on top of each other. But we're looking specifically for a solution that's going to have an x and a y coordinate, or a solution to the x and the y. We're going to solve it by substitution. The first step is to solve for one of the variables in terms of the other. And here we're going to choose this one to solve for y and get it by itself because its coefficient is 1. If I were to solve for the x, say down here, I would have to divide everything by -5 to get the x by itself, and that would give me fractions. I don't want to deal with fractions. Here I don't have to divide by anything. So I'll take this first equation and I'll rewrite it. Let's see, 4x plus y is equal to 15. And now to get the y by itself, I need to do the inverse operation. Here I'm adding 4x, so I'll do the inverse operation, which is to subtract 4x minus 4x. Draw my line. You end up with y is equal to 15 minus 4x. Everywhere I see y, I can substitute this expression, because that's what it means. So I'll take my second equation and rewrite it. -5x minus 3y is equal to -24. And everywhere I see y, I'll substitute this expression. So rewriting it, I get -5x minus 3 times the quantity 15 minus 4x is equal to -24. And now we solve for the x. We have one equation with one unknown. We'll solve for the x. And then we'll plug it back into one of the two equations to solve for the y, so I'll have my xy solution. To solve for the x, first it will expand. -5x minus 3 times 15 is 45. And I have a minus times a minus, which makes this a plus. 3 times 4x is 12x is equal to -24. Combine like terms. I get 7x plus -45 is equal to -23. And I'll add 45 to both sides of the equation to do the inverse operation to try to get the x by itself. Here I have 20, oh, sorry, this should be 24, this will be 21. 7x is equal to 21. Again, do the inverse operation. The inverse of multiplying is to divide. Divide both sides by 7. End up with x is equal to 3. Now to solve for y, we'll substitute it into one of the two equations. It doesn't matter which one. So we'll select the first equation. 4x plus y is equal to 15. And I'll substitute 3 everywhere I see the x. 4 times 3 plus y is equal to 15. 12 plus y is equal to 15. And when you subtract 12 from both sides of the equation, you end up with y is equal to 3. My solution is the x is 3, so it's 3, and the y is 3. The last step we need to do is to check our work. So we'll plug this value back into both equations from the original. Our first equation, when I substitute 3, I get 4 times 3 plus the y was 3 is equal to 15. Now here we have 12 plus 3 is equal to 15. So it checks with the first equation. Next we'll substitute 3 for x, 3 for y, which is our solution, back into the second equation. -5 times 3 minus 3 times 3 is equal to -24. A -5 times 3 is equal to -15. -3 times 3 is -9, equal to -24. And yes, that checks, so that is our solution. Let's try a second problem as an example. Here, can you tell which equation we should use, which variable we should solve for? It would be the second one because this has a coefficient of 1. And then when I divide everything by 1, I don't end up with any fractions. So I'll use the second equation. I'll rewrite it. I have x minus 2y is equal to negative 9. To get the x isolated and by itself, isolate the variable, we'll add 2y to both sides of the equation, plus 2y. Doing the inverse operation, inverse of subtraction is to add. So I have x is equal to negative 9 plus 2y. Everywhere I see x, I can substitute this expression. Now I've used equation number 2 to solve for this, so I will plug this variable back into equation number 1. 7x minus 3y is equal to negative 19. Now everywhere I see x, I'm going to substitute this. And notice how I circle it and draw an arrow. If you want to do that, that's the best practice. 7 times negative 9 plus 2y minus 3y is equal to negative 19. Well, let's use the distributive property. 7 times negative 9 is negative 63. 7 times 2y is 14y minus 3y is equal to negative 19. Combine like terms, negative 63 plus 11y is equal to negative 19. I want to get the y by itself, so I'm going to do the inverse operation here. We'll add 63 to both sides of the equation. And I have 11y is equal to 63 minus 19 is 44. Divide both sides by 11. Again, with inverse operation. And you end up with y is equal to 4. I still need the x, because the solution is going to have an x and a y. It's where the two lines cross. It's a coordinate, x and y. I can substitute this value for y into either of the two equations. I'll select the second equation. Second equation is x minus 2y is equal to negative 9. Everywhere I see y, I'll substitute this in. X minus 2 times 4 is equal to negative 9. X minus 8 is equal to negative 9. Again, we do the inverse operation. Add 8 to both sides of the equation to get x is equal to negative 1. My solution, x, y, is negative 1, 4. And to check my work, I will substitute this for x and for y into both of the original equations. So I'm going to substitute negative 1, 4 into the first equation, which will give me 7 times negative 1 minus 3 times 4 is equal to negative 19. Here you have negative 7 minus 12 is equal to negative 19, and yes, that checks. Now we'll substitute this back into the first equation, the second equation. So you have negative 1 for x minus 2 times 4 is equal to negative 9. You have negative 1 minus 8 is equal to negative 9, and yes, it checks. And this is using substitution to solve a linear system of two equations, two unknowns. Good luck and success.